Hi, welcome back to LeetCode. So in this video, I am going to discuss the third problem from today's weekly contest 485, that is design auction system. So you are asked to design an auction system that manages bids from multiple users in real time. Each bid is associated with a user ID, an item ID and a bid amount. Okay, so we have to implement this auction system class, or actually have a constructor auction system which actually initializes the auction system object. Now we have a member function that actually add bid, or actually we have three arguments. So one is the actually user ID, next is the item ID, and this is the bid amount. Okay, that means we are trying to add a new bid for this particular item and by this user ID, and this is the bid amount, something like that. This is the statement. Now adds a new bid for item ID by user ID with this bid amount. If the same user ID already has a bid on this item ID, replace it with the new bid amount. Okay, and we have another member function that is update bid, or actually we have that whatever the old bid amount actually that person actually have, that user ID actually have, that will be override with the new bid amount. That means update the existing bid of user ID for this item ID to new item, new amount. It is guaranteed that this bid exists. Now we actually other member that is a remove. So someone actually previously it was actually bidding on some amount, some item. Now he do not actually, he wished to actually do not want to bid that item. So he can actually remove that, correct? So that's why to remove that, you can see that removes the bid of user ID for this item ID. It is guaranteed that this bid exists. Now we have another function, member function, that is get highest bidder, and we have parameter is the argument is item ID. So that means for this particular item, so there can be multiple like auction, in a auction system we can actually have multiple item, right, to be actually auction for this auction. So return the user, so for this particular item ID we have to return the user ID of the highest bidder for this item ID. If multiple users have the same highest bid amount, we have to return the highest user ID. Got it? If no bid exists for this item, return -1. That means we will get three things. So we actually have add bid, we actually have user ID, item ID, and the amount. Correct? Similarly, we actually have update bid. So similarly, we have user ID, item ID, and new amount. And remove bid. So we actually have only user ID, who is trying to remove from this current. So what we wish to actually remove, withdraw from the auction. So this is the user ID, and for which item. Correct? You can see that we actually have two argument only. One is the user ID and the item ID. Okay, and we have another function that actually get highest bidder. So we want to know, right, that after some time we want to know that we actually own the actually bidding. So for this we actually need the item ID. Okay, so you can see that somehow we have to map this. There can be multiple suppose item 1, item 2. So for this item 1 we want to know who is actually highest bidder, right? User ID, correct? So and similarly for this item 2 I want to know who is actually the highest bidder, user ID. Now you can see that, try to map that. We can actually, in the add bid we actually have three things. One is the user ID, another is the item ID, and another is the amount. Okay, so this is to add. Now if I want to remove, they mention that we have to remove from this map also, that for this particular item ID, if suppose the person 1 is actually the highest bidder previously. Now if he wishes to remove from this auction system or bidding, then I have to remove from this map also. I have to adjust this also. So somehow we have to sort this, right? Sorted. Suppose this example, person 1, item ID is 1, amount is 10. Okay, next is person is 1, item ID is same, it is suppose 15. Okay, this is suppose add and this is suppose update, and for remove I want suppose person was going to want to withdraw from here and item ID is 1. So you can see that previously for item ID 1, okay, we can say that person 1 actually bid amount is person 1, person user ID is 1 and the bid amount is 10. So after this update operation, we will modify this. First of all, remove this data and modify this, that user ID is 1 and current bidding amount is 15. Okay, now if I want to remove this, that means there is no bid request for this particular item ID 1. I'll remove this. Got it? So I have to somehow we have to store this, that for this one item ID store the sorted data on the basis of actually bid amount. Correct? Now when I'm trying to update this, okay, suppose this is second time, this is the update operation. That time we need to know that what is the previous amount actually for this person user ID, same person user ID. So somehow when actually this is the update operation, we have to know, we must know that what is the previous bid amount for this particular same user ID. So previously for this item 1 for user 1, the bid amount was 10, right? Now second time when I'm trying to update the bid amount, now we have to first remove this value from this map or sorted vector, invalidate that this data is no longer actually valid because user has already modified the value. So that's why we need to know that the previously what value was actually for this user ID. Correct? So for that we can actually use 2D map to know that for this particular item ID what is actually amount bidded by this user ID. So first 2D map, first key will be the item ID, right? And next key 2 will be what is the user ID, and ultimate value will be what? Bid amount. This is clear? So from this 2D map I can easily find out that for any user ID, if there is any already record or not for this particular item, because it may possible that person 1 actually bidded for multiple two items, one for the item 1, one for the item 2. It possible, but he want to modify only that item 1 only, suppose, but item 2 still it's valid. So that's why for this item ID particular, I have to know that for this user ID what is actually the bid amount. Correct? So from this 2D map we can easily get it, right? We'll get it. So how much time it will take? If I use another map, it will take big of 1 roughly, because another map we know it will take actually big of 1. Okay, now we want to know that for this any item ID what is the highest bid amount. Correct? We want to know that. So if I want to know what is the highest bid amount, so that means that somehow we have to store the bid amount in a sorted order, somehow in decreasing order or in increasing order. Both are possible. So suppose I know that for this user ID, item ID is 100 and bid amount is suppose 10. Okay, and person 2 for the same item ID, suppose bid amount is 20. So somehow we have to know that for this item ID, I have to store somewhere that okay, person 1 and the bid amount is 10, person 2 bid amount is 20. So in this sorted order we have to store that. Correct? On the basis of actually the bid amount. So I'll sort on the basis of bid amount. Now it will actually take n log n to sort every time. So suppose we modify something and if we sort this vector again or array again, it will take n log n, we know roughly. So if actually you set here, you can see that we can easily actually find out that by using log n instead of n log n. So we know that set is also work in the same way, alright. It will also store in the sorted order. Now suppose for this item 100, item 1 person 1 bid amount was 10, person 2 bid amount is 20, person 3 bid amount is 30. Suppose this is the three record till now. 3 person actually bidded on the same item is 100. Now in the 2D map, we can easily find out that for this item ID, user ID 1, bid amount is 10. For this item ID 100, person ID is 2, bid amount is 20. Item ID is 100, person ID is 3, bid amount is 30. Now suppose I want to update this. Suppose update by person 1, item ID is 100, and previously it was 10, now it is suppose 15. Suppose 25, it will be better. 25. Now how actually you can easily handle this sorted array? So previously we know that from this 2D map, okay, that what is actually the old bid amount value. It is for this item ID. First I will go to this 2D map, key is the item ID and user ID is the second key. Okay, user ID is 1, what is the value? 10. Okay, so I know that in this set, this is set, so I know that this is actually sorted order, and what is actually value I have stored? The user ID and the bid amount. So I can easily check that what is the position for that. So what will be the pair for that? User ID 1, old value what is it? 10. So first what will do? I will first remove this from this set. Okay, it will take log n, clear. Then I will add 2, 20 and person 1 25, person 3 bid amount is 30. In this set again, actually insert this value into a set again. First remove this. So first step is remove from set by using user ID and the old value, correct. Next, insert the new value into the set. So I will actually store user ID and the new value. This is clear. So again this will take log n, this will also take log n. Got it? So in this way, by using the set, I can actually store that the order, the increasing order of bid amount, correct. So in the end I actually have the highest bidder. So if we actually have the same bid amount, suppose both the person 1 and person 2 have the same bid amount, so they mention that if we actually multiple answer or multiple highest bidder, then actually you have to return the bidder who actually the highest user ID. So you know we are already in the set actually if both the actually bid amount is same, then actually store according to the actually the user ID. Got it? So that's why whatever the values you store at the end of the set, that will be our answer, correct. So here also it will actually kind of map the item ID and the set of pair, correct. So first item is that we can actually have this get hashed bidder. That function can be called for any item. So that's why we need to know that for this item ID, any item ID, whatever actually the sorted set actually I have sorted values, correct. So that's why I need to store in a map. Got it? And to update and add any new bid for any user ID and on the basis of some item ID, we have to use a 2D map also to track that what is actually previous old bid amount, and if they want to update anything, that time he or she can easily remove this from the set for this particular item ID and add the new bid amount. Correct? So this is the one map, and second map it is the 2D map. Or actually you have map of, first is the item ID, then we actually have map of user ID and bid amount. Clear? 2D map, the first key is the item ID, because any one person can actually bid multiple items. So that's why first key is the item ID for this particular item ID for this user ID. So that's the second map. So for this user ID, what is actually the bid amount currently. Now if you want to update bid amount, it's bid amount, then he can actually first remove from the set by using the old value, and then insert the new value with the same user ID. So anytime this map is also consistent and this map is also consistent. Clear? So now go to the code. If you have any doubt or any suggestion, you can comment on that. So you can see that we actually have two map. Okay, so here you can see 2D map. So first is the item ID, and for the next second 2D map, so next key is the user ID, and this value is the ultimate bid amount for this particular user ID. Okay, and next map is that we have to store the there are multiple sorted vector possible, because there are multiple item ID possible. So that's why to store that effectively, we can actually use a map that for this particular item ID, what is actually sorted vector or sorted set here actually. But so that's why we are using the second map, where actually the key is the item ID and set is the value, but set actually store the sorted values of the bid on the basis of bid amount. Clear? And here actually you have bid pair. Pair is the first is the bid amount and the user ID. Clear? So you can see that when we're calling the add bid function, we actually have this user ID and the item ID and the amount or the new amount. So first of all, we have to check that this user ID is already have some old bid amount or not. So how we can check that? We can use this 2D map. So first of all, I'll go to this item ID okay, I'll check that do we actually have any entry or record for this user ID. If it is not 0, count will not, it will return 0. If there is no record, it will return non-zero if you have some record on this particular user ID. So that time, first of all, we have to erase that, because we are trying to add new bid amount. So that's why first erase this from this 2D map. So sorry, not 2D map, from this set. So that's why how can we access that? So q of I for this particular item ID, first we will get this set, whole set, and from this set we have what have to remove? The old bid amount and the user ID, because that was actually the data we have stored into the set. So you can see that erase, we are erasing. The first is the old bid amount value. So how shall we get this? We get from this 2D map. M of I is the item ID and this 2D map, and next key is the user ID, and how from this we will get the what is the bid amount, previous bid amount or old bid amount, and next element is the current user ID. Correct? First of all, remove this from this set. Okay. Now we are trying to add this new entry, so that's why we have to again modify the value. It is set also and also the 2D map also, because next time if we again call this add bid function, we should actually get the updated value from the 2D map, that this is the new value or the current old bid value by this user for this item ID. So that's why you can see that for this M of I, this map, 2D map, first is the item ID again, and this is the user ID, and this A is the current new bid amount value. Also store this in the set also, because after it is not possible that after this add bid function we may call this get highest bidder function. So that's why also we have to actually manage the set also sorted array. So that's why for this particular item ID in the next second map in the QI for this item ID we are storing this A. A is the new amount, new bid amount value, and for this user ID. So our set is also consistent now. You can see that for any item ID, we will get the consistent. And also from the 2D map also, we can easily find out what is actually the old bid amount value. So next function is update bid. Here also the same. We are trying to add this new entry or new record, but also we have to override that. They mention that if we have any record for this user ID, we have to remove that, and then actually we have to add this new amount. So that's why I again call this add bid function internally, passing this same three things: user ID, item ID, and the amount. So again, if we already have some record against this user ID, it will actually return true, this if block, and it will first remove the data from the set. Got it? And then actually override this. And how to override this? First of all, override that in the 2D map also, and also store the updated value in the set sorted order. Got it? And now we have to remove bit. Here also you can see that directly we will get two things. We will get two things. One is the user ID and the item ID. That means for this particular item ID, we have to remove the record for this particular user ID. So that's why first of all we have to remove from this 2D map also, and also we have to remove from this set also. So that's why first of all remove from the set, because to remove from the set we need to know what is actually the current bid amount and what is the user ID. So how should we get the current bid amount? We will get from the 2D map. So that's why first of all removing from the second map, erase, and first get the what is the current bid amount value for this particular user, m of I of u, item ID, and then the user ID. I will get the current bid amount value and the user ID. So this is actually the pair. Now it will be removed from the set. Also, after this remove from the set, we have to also remove from the 2D map also, that if next time if we call any add bid or update bid function, we should be actually telling us that there is no record for this particular user ID. So that's why for this particular item ID, we have to remove this user. Got it? Clear? Now we have to know another function, that is get highest bidder. So for this particular item ID I, we want to know that which is the actual highest bidder. We have to return the user ID. So they mention that if there is no record, no bid exists for this item, return -1. So how we can find out that is there any bids exist or not for this particular item ID? Our set will be empty for this particular item ID. So that's I will check that for this item ID QI, is it empty? If it is empty, that means true, I will return -1. Else whatever the actually record present at the end, because this is actually sorted in the increasing order. We know how actually we store in the set, in increasing order we store. So that's why whatever the data present at the end, that is actually the highest bid amount. Or it may possible that if the multiple actually have the same bid amount, it actually have the highest user ID. So that's why we have to return that ultimately, whatever the user ID actually present. So that's why I will go to the end of this set. QI actually return the from the second map of item ID, we will get the set, whole set. And if I call .r begin, it will return the end of the set, end element, or the rightmost element. And what are the second element? Because there is a pair, you can see that ultimately each record is actually a pair. First record is or the amount, and the next record is the user ID. So that will return. So that's why I return the second element, whatever the present at the second, it is the pair. Got it? I hope this is clear. It is just actually how we can use effectively the data structure actually. Got it? So I have shared this in the description. You can check that. You have any suggestion, any comment, any doubt, you can comment on that. And if you're not a subscribe, please subscribe channel. Thank you. Bye bye.